This is the weight. You calculated the weight. How much you got? Your question was how much force it is pressing it
At the pivot. I have that. The earlier question is easy to find the weight.
That is easy. So net force here should be 0. Correct? Net force should be 0. Net force or just force?
So the force with which is this push. The force with which the pivot is pushed, I guess. Yeah, that is the question.
So in a balanced condition, the entire weight. Now, what was the weight of the rod?
I just didn't know the second part, the sub part. I know the first part. I have to calculate it.
See, since there is no displacement, right? There is no displacement. So what are the upward forces? Upward forces is force of reaction, right? And this should be force, whatever force. Let us say some force. Some force. Now at equilibrium condition, add all the forces downwards. What are the forces downwards? This weight and this, correct? So that's one. You need two equations. So basically, net force. So let's say this is F1, F2, and this is W. So F1 plus F2 plus W must be equal to the reaction, right? What is the force upward? The reaction force. Now, we need one more equation to actually get the reaction. Then we can, because there are two variables, F2 and R. Okay? So the only way is one is net force 0, the other is net torque 0. Right? So by forming net torque 0, just see if we can adjust this. Okay? So I'll take this, I'll try it. It's not very simple. Where this question was asked? So online there could be some tricky questions. Is the answer there? Is the answer available?
Yes.
What's the answer?
Weight was.
Not the weight, for this.
It was the addition of the weight and the force and the weight of the object. Weight of the scale plus weight of the object.
Exactly. So that's what it should be, right? Because at net force 0, तो वही तो होना चाहिए. This side force should be equal to this side force. देखो, whatever is the reaction, the total of this force should be acting here in equilibrium condition, and that force should be balanced by reaction. Exactly, that's how it should be. Isn't it?
So we have to write that statement. You have to write a statement that net torque is 0.
Net downward force should be equal to net upward force. So what are the two forces downward?
Weight of the scale and weight of the.
Net downward is that only. And that is only, what is the upward force? Only reaction. That reaction must be balancing these two forces. Got it? So obviously, yeah, then this. So you have to do such questions only by equilibrium.
So net torque should be big
No,
on
net torque is not required actually, because upward force is only reaction. And what are the forces acting downwards? The weight and the hung force. Okay. So reaction must be balancing these two. That is why it is not going up or down. Okay. That, and so whatever is reaction, okay, equal and opposite to that must be acting downward on the pivot. So that's what it is. Okay. All right. In the energy transformation, somebody asked me a question. Energy transformation regarding kinetic and potential energy. Who was asking that question? Ah. So basically, see what is happening here is, so the question was, what energy transformation takes place when water is converted into ice? Correct? This was the question. What energy transformation takes place when water is converted into ice? Yes. So water is what? This is liquid state. And this is solid state. So which question number it is from the volume? Just check what page and which question it is. Page number, page number, page number 38, 7, right? Question 19, 7 part. Okay, this is page number 38. So in liquid state, right, how is the bonding as compared to solid state? Bonding is weak or strong? Weaker. And liquid molecule are constantly in motion, right? So what kind of energy it will have? Kinetic energy, right? And what about ice? It is solid form, so the bonding is stronger, right? So what about movement of molecule? Will it be mobile as liquid? Will it be as mobile? No, it will be lesser. So obviously, in going from here to this state, the kinetic energy will come down. Right? So the kinetic energy here is converted into potential energy. Now this can only be answered at the atomic level. It's not very obvious. The energy changes are not very obvious. Only at the atomic level you can answer. But even in solid state, it's not that the kinetic energy is completely disappearing. In solid state also, the atom vibrate at their main position. But it does have kinetic energy there also. So it's not that the kinetic energy is totally converted into potential energy. But if at all there is any conversion, it will be kinetic to potential. So it will be the loss in kinetic energy will be gain in potential energy going from here to here. But it also will have kinetic. Okay? Is that clear? So you can answer this way, kinetic to potential. All right. So any more questions on work power energy? If not, we'll move on to next chapter. Anybody has question from second chapter? Okay, let's proceed then. Online students, any question from work power energy?
No doubt, sir.
Okay. Who is Kabir? Rishant. This is a new edition. Okay, let us begin with machine. So, why do we need machine for? Make work easier. Very good. So this is so machine helps. It helps. In what way? One is to make work easy. Okay, what else? Safe, correct? More safer. What else? Fast. Reduces time of work. All of these, right? Change of direction. Yes. So it offers convenience. So a lot of things, right? That's why we need machine code. I mean, if we don't employ machine, we'll end up doing like one task in a day, for example. Otherwise, it allows us to do multitasking, right? So all these things, right? So there are certain terms which are associated with machine, which will be helpful in classifying one machine from the other machine. Even amongst machines, just like us, our capabilities are different. Okay. So how to differentiate amongst different machines, right? For that, we need to be familiar with certain terms. So let us see what are the terms associated with machines. Right. So first is load. Okay. When I talk about machines, we are not going to learn very complex machines. Very simple machines are being, you are supposed to learn about very simple machines. So two such machines that we learn is, what are the machine you are going to learn about? Lever and pulley. Okay, you're going to learn about these two machines. So these are very primitive, basic machines, right? And now today we have very automated kind of machines, but this is mechanical machine, right? So everything that we're going to learn is very basic. So these terms are basically to describe these machines. Okay. So a load is the weight or resistive force. What is load? It is weight or resistive force to be overcome by machine. So load is something on which actually machine works. It lifts the resistive force or weight. So basically it is nothing but it is a force. Load is a force, right? How do we denote it? We denote it as L. Okay. Next is effort. No, effort is the force that we will apply on the machine. I mean, machine will not work on its own. Okay. So we got to apply some effort on the machine so that then machine will work for us by lifting the load. Okay. So this is the, it is the force. Both are force applied on the machine. Got it? So this is the force applied on the machine so that it starts working on the load. Then how do we relate load and effort? It is related by a quantity called mechanical advantage. Okay, mechanical advantage or MA. Right? So MA is defined as ratio of load to effort. Right? Or L upon E. Okay, so depending upon this ratio, we have different types of machine. Okay. So what could be the value of load upon effort? If load is more than effort, then the ratio will be greater than 1, right? So we have three different types of machines possible. Mechanical advantage greater than 1, mechanical advantage less than 1, and mechanical advantage equal to 1. Is the full screen visible?
Yes, sir.
Okay, so the last part is MA equal to 1. So depending upon the value of mechanical advantage, machine has different functionality, right? So what does MA greater than 1 means? It is a force multiplier. That means the machine is able to lift a very large load for us on the application of very small effort. That's when you'll have mechanical advantage greater than 1. So in this case, effort is less than load, and the machine works as force multiplier. Right? So in this case, effort is less than load, and that's why we are getting mechanical advantage greater than 1. When the mechanical advantage is less than 1, it means effort is greater than load. And in this case, machine provides speed gain. Meaning it delivers the work fast for us. And we'll see it with examples. And in the third case, effort is equal to load. Right? So in this situation, machine provides change of direction. Change of direction. Okay, so let us understand it with the help of example. Can you think of a machine which acts as a force multiplier? Yes. Hydraulic press. Yes. So in 9th standard, you learned about the Pascal's law and all that, right? So with a little bit of pressure, you get a bigger force. Small pressure, that means small force, results into a bigger force. So that is a force multiplication. In the hydraulic lift. Okay. What about speed gain? Scissors. How? When you have to explain. Scissors is correct. So what do you get in scissors? What is speed gain? So it will become more clear when we discuss what is called as velocity ratio. Okay. So basically what happens is, look at how much effort is moving. So you're applying effort on the handle, right? And it moves a small displacement. Let us say displacement of effort. Right? This movement of handle is because of the effort you're applying here. And let us say you have a paper here or anything that you want to cut. right? So the work it will deliver is by cutting a very long length. Okay, so a small effort is actually providing you a bigger displacement of load. You get it? So what are you getting? Speed gain in terms of time. The time taken for both the displacements is same. In the time in which the handle moves this much, the work output is very long displacement cutting, right? Okay, so that is kind of speed gain. So to understand speed gain better, let's describe what is called as velocity ratio. Velocity ratio or VR. So how VR is defined is, it is defined as the ratio of velocity of effort upon velocity of load. Okay, velocity of effort upon velocity of load. So what is velocity of effort? Displacement of effort divided by time. Divided by what is velocity? Displacement upon time. So displacement of effort upon time divided by displacement of load by time. So what you get is d by dl. So this is velocity ratio, right? So for speed gain, d is less than dl. Okay, when de is less than dl, that is when you get speed gain. Correct? It is also true in case of knife. So knife has a small handle and it is a very long, sharp edge to cut things, right? So let's say you have a pizza, okay? And you hold the knife like this and run it by 1 centimeter. But a 8 centimeter long pizza can be cut. If the knife sharp edge is about 10 centimeter, you can cut a 8 centimeter pizza by moving the handle just 1 centimeter. Okay? So you're getting a big displacement for load. All right. So displacement of load is, I think this, either this or this. Let's see. Okay, so for speed gain, so MA and VR are two parameters which describe or differentiate different types of machines. You get three ratios here also. Okay, similar to MA, if VR is greater than 1, it acts as force multiplier. Right? VR less than 1, it acts as speed multiplier. And VR equal to 1 provides change of direction. Okay, so MA value and VR value gives you the same type of machine, right? So these are just two different parameters. So this is force multiplication. Force multiplier. This is speed multiplier. And this will provide change of direction. So in change of direction, there is no advantage of effort or load. You have to apply effort equal to load only. Thus the direction of operating the machine becomes convenient. Okay. So we will understand it with the help of some machine going forward. Right now you first take this down. So what is velocity of effort? This is VE upon VL. So by definition, it should be displacement of effort divided by time, and in the same time, the displacement of effort take place is also the displacement of load take place. So T gets cancelled. So are we okay till here? Are we okay till here? So these are the parameters that will be deriving for all the machines that we are going to learn now. So the load is running over here, right? Displacement of load will be this only. By the time this is PE, this is DO. Right? Load is there is load carrying. So that's running. The blades are running over how many? That way I'm taking even and but it is slightly not clear right now. So when we get it lever, we'll see how it works. We'll come back to the next one. Okay. But it suffices to say, like, you got the idea what is displacement of load. See, if you're lifting a load, there is very clear displacement where the load is being lifted, right? But in this cutting case, it's running over. Okay, so that's why. Generally, if it is lifting case, then effort goes down and the load goes up, like seesaw. Okay, those are different. But there it is slightly different. And there is also a load arm and effort arm. That's different. Arm is the length from the pivot on both sides. So the displacement is different and the arm is different. Get it? So what is written as DL right now, horizontal, that is also load arm. That's why the displacement has to be vertical. Just like, okay. And it will be given because this side is scissor. Effort is less, right? DL has to be low. Okay. DL has to be low. It will become clear. Okay, I would like to let you know that treat this as DL. There is some confusion out here. Okay. So from the pivot, this horizontal length, this will be called as load arm. Load arm. Okay. And this will be called as effort arm. Here, effort arm. Okay. So let us keep the DL as vertical. Okay, both vertical. Right. And this is load arm and effort arm. Okay, so how many things we have learned about machine right now? Load, effort, then 3 values of mechanical advantage and 3 values of VR, identical. So if the value of mechanical advantage is greater than 1, it means machine act as force multiplier. MA greater than 1 or VR greater than 1, same result, force multiplier. Okay, MA less than 1, VR less than 1, speed multiplier. Okay, MA equal to 1, VR equal to 1, both are providing change of direction. So what is change of direction? I will just tell you. So let us say you have a pulley. Huh? Somebody is lifting a load directly, like pulling up a bucket full of water from the well. Let us say you directly pull this up. So will it be convenient? Huh? Pulling a bucket from well like this directly, will it be convenient? No. Now if I put it over a pulley, right? Let's say we have a pulley over here. Now how the effort is applied? Now the effort applied is over here. So it is not convenient Now effort is in this direction. So when you're pulling it now, you can also use your body weight, right? Earlier, you had to use your strength, muscle strength. Okay, no body weight was used. But in this case, when you use a pulley, now the direction of effort is downwards. So it is much easier to pull now. But if you're pulling it directly up, then you have to apply your muscle strength only. No support of your body weight. Okay, so this is change of direction. In this situation, no difference in the applied effort. Just the direction is changing. Okay, and it becomes convenient, right? So, and force multiplier example is, you can say bicycle. Okay, one more thing is, we should have written point of application of effort. In the machine's benefit, there's one more point. It allows you to apply effort at a convenient point. Four things that we wrote, उसमें और एक add करो. Machine also allows you to apply effort at a convenient point. Huh? In which case this point is 1 second. So we'll see that. We are going to use so many examples of it. Yes, what was your thing? What have you written? Allows what? मतलब पहले क्या है? Machine allows to apply effort at a convenient point. Clear? Allows to apply effort. Allows to apply effort at a convenient point. Now in bicycle, allows effort at a convenient point. So bicycle में, what makes the motion possible? The motion of the rear wheel. But how do you rotate the wheel? By sitting at the seat, and where is the pedal? It is conveniently located, right? I mean, you don't. ऐसे ऐसे नहीं करते पीछे का नहीं चलाते सीधे बैठो ना convenient ऐसे. And how do you transfer the effort with the chain? With the chain, right? So you are applying effort at your convenient point at pedal, and it is transmitted through the chain with the help of gear pulleys to the rear wheel. वही है ना मशीन, तो मशीन में यही है convenience, ठीक है? Okay. So we have to see all this for every machine. We have to now calculate what is the mechanical advantage, what is VR, and what is your efficiency, etc. ठीक है? और लिखो आगे लिखो. So does mechanical advantage and velocity ratio has any unit? Is it a ratio of same point? Okay. Next is efficiency. Okay, work input. That's called WI. So machine will not work independently, okay? You have to work on the machine and then machine works for you, right? Machine खुद से तो काम नहीं करेगी, होना भी नहीं चाहिए, right? It should only work at your command. So when you are commanding or operating machine, you are first working on the machine, right? So what is work input? So it is the work done by applying effort on the machine. On the machine. Right? So it is the work done by applying effort on the machine. So what is work input? It should be effort multiplied by displacement of effort. Because work is force into displacement, right? So this is a work input on the machine. What is work output? Output. WO. It is the done by the machine by overcoming the load. Okay. So we did work on the machine, and machine is delivering work output by working on the load. Okay. So work output is load into displacement of load, right? Next is efficiency of the machine. Efficiency of the machine. So we are going to learn about efficiency here, but there were questions related to efficiency in the previous chapter, right? So what is efficiency? It is the ratio of work output upon work input. So how do you define efficiency? Efficiency is defined as work output upon work input. Okay. Now, since the time involved in providing work input and the work delivered is same, it can also become power output and power input. Correct? Since time is same, it will be power also, or energy output upon energy input. The same efficiency formula can take different forms. Got it? The ideal thing is efficiency is the comparison of how much work is delivered to how much is being invested or inputted into it. So output over input. So what is good? Bigger the number, better it is. Correct? So an efficiency percentage, how much it will be? Yeah. So this is what it is. An efficiency in percent is equal to WO by WN. Okay. So what should be the efficiency for an ideal machine or a perfect machine? 100%. Whatever you are investing in it, everything is delivered to you as work output, but it never happens in real life. Why? Because of frictional losses. Machine has got moving parts. Okay. So every energy that you are supplying into the machine will not be converted into useful outcome. Some of it will be converted into heat energy, which is gone. So generally, for real machines, efficiency is less than 100%. That is, efficiency is less than 1. Only for ideal machine. ठीक है, इसको ये भी लिख लो. Less than 1 due to frictional losses. Due to. So you can't avoid friction, right? It is ever present. So frictional or dissipative losses. So for ideal machine, efficiency is equal to 100% or 1. So only for ideal machine. Okay, so what do we learn at the time of learning? We will learn about ideal machine only. Okay, so for learning this is easy, and then we can compare with the real machine. Okay, so the more close the efficiency is to 1, that much better the machine does. Okay, so all these terms are defining properties of machine. Are we good till here? Okay. Can I erase it? Bolo? Yes,
Yes,
no, no.
sir.
Next is, I have to write the relation between MA, VR, and efficiency. So let's now see what is the relation between mechanical advantage, velocity ratio, and efficiency. So since this is load into right. So this is now L by E. Now what is L by E? MA, and what is D by DL? Yeah. So this means we have so this is the relation between mechanical advantage. Can you keep the back side, please? So the relation between efficiency, mechanical advantage, and VR is this. So what do you conclude from this? Since efficiency is equal to 1 only for ideal machine, MA will be equal to VR only for ideal machine. For all other cases, efficiency is less than 1, and therefore MA will be less than VR, right? So for ideal machine, MA is equal to VR. For real machines, MA will be less than VR. Why? Since okay. So for all practical machines, mechanical advantage you will get will be always less than VR. Okay? Plain mathematics, right? Because this factor on the right, it will be less than 1 for real machine. So ये equality क्या हो जाएगी? Inequality में change हो जाएगी. Is that clear? So this is pure mathematics. Is everybody comfortable till here? Huh? Any questions till here? Okay, next. Next is principle of ideal machine. So, yes. So for ideal machine, eta is equal to 1. This gives. So this is the principle of ideal machine, right? That is work input. Work input equal to work output. Or energy input okay. So it is written in various forms, work or energy, same thing, looked in different contexts. Okay. So having defined all the terms associated with machines, now let us read about actual machines. So the first machine that we learn is lever. So actually, this is nothing new. Like wherever there is ideal machine, efficiency becomes one. Just the play of definitions. Okay. So far, we have only become familiar with 4 terms: load and effort, and मैकेनिकल एडवांटेज एंड वेलोसिटी रेट. अभी तक 4 ही चीज सीखा है, बाकी उसी के साथ प्ले कर रहा है. ठीक है. एफिशिएंसी यू नो यू मस्ट हैव learned about it in different contexts. It is the ratio of output versus input. Whatever you do and how much you are getting, that's the interest, right? Whatever effort you are making and how much you are getting. Even in real life, it is like that. You only get what you deserve. जितना effort, उतना outcome. तो मशीन के केस में भी ऐसे ही. लेकिन मशीन के केस में we try to be little clever. अब जितना एफर्ट उतना ही आउटपुट मिलेगा तो फिर फायदा नहीं. हमको क्या चाहिए? मल्टीप्लिकेशन चाहिए. लेस एफर्ट, कम से कम एफर्ट और ज्यादा से ज्यादा आउटपुट. दैट्स व्हाई वी रिक्वायर मशीन, राइट? ठीक है. सो व्हाई अदरवाइज वी वुड रिक्वायर मशीन? बिठा दो उसको. यस सर. Okay, so the first machine that we are going to learn is lever. तो लीवर के बारे में पढ़ा होगा तुमने लोअर ग्रेड्स में, पढ़ा है कि नहीं? तो क्या होता है लीवर? लीवर होता है एक डंडा. क्या होता है? डंडा. ठीक है. और इंग्लिश में क्या बोलते हैं उसको? रॉड. इसको डंडा बहुत पसंद है ना. Okay. So lever is either a straight or bent rod. It is a straight bent rod fixed at some point. ठीक है? लीवर ये होता है स्ट्रेट रॉड फिक्स्ड एट सम पॉइंट. वो पॉइंट बीच में कहीं पे हो सकता है या फिर साइड में हो सकता है. ठीक है? So depending upon where is the fixed point, there are three types of or three classes of lever. So there are, and what is this fixed point called? There are three classes. The fixed point is called fulcrum. Fixed point को क्या बोलते हैं? Fulcrum. So types or classes of lever. ठीक है? Depending upon where the fixed point is, we have three categories of lever. So class 1. So in class 1, fulcrum is in the middle. In the middle. ठीक है? And what is on the other side? Load or effort. मशीन में तुम्हें पता है मशीन का क्या काम है? लोड ओवरकम करना. कैसे? by the application of effort. ठीक है? But lever में क्या है? Straight or bent rod, it has to be fixed at that point. So fixed at some point. So when the fulcrum is in the middle does not means midpoint. What is the meaning of middle? No, it is, if it is giving you the idea about center, then it is not in the center. You can say fulcrum is between load and effort. Fulcrum is between load and effort. ऐसे करो. Middle का मतलब है mid point में नहीं होगा हमेशा. ठीक है? So now what is the mechanical advantage for class 1 lever? Because this fulcrum could be anywhere. Depending upon the position of the fulcrum, MA in this case could be greater than 1, less than 1, or equal to 1. So, depending on position of F or class 1 lever, MA equal to 1. ठीक है? तो class 1 lever can be made into a force multiplier or a speed multiplier or a direction changer. So we can design class 1 lever according to our need as any one type of machine. Once the machine is designed, it will have only single mechanical advantage. एक ही machine force multiplier भी, speed multiplier भी और direction changer नहीं काम करेगी. तो एक ही function आएगा उसके अंदर. ठीक है? So let us see the example of class 1 lever with mechanical advantage greater than 1. So example of can you think of an example of class 1 lever with mechanical advantage greater than 1? What is the condition? Caesar. क्या बोल रहा है? और तुमने क्या बोला? तो सीजर भी लीवर ही है. संक्रम है कि नहीं उसके अंदर? हाँ देख अभी आवाज बढ़ गई उसकी. गलती से सही है. सीजर भी एक लीवर ही है. हैंड पंप इज अ फोर्स मल्टीप्लायर. हैंड पंप में क्या? हैंडल ऑफ हैंड पंप. हैंडल है. हैंडल कहाँ पे फिक्स होता है? यहाँ पे. और एफर्ट वाला जो आर्म है ये लंबा है. ठीक है देखो देखो यहाँ पे listen how to calculate mechanical advantage. लीवर को जब हम यूज करते हैं राइट, ऑलवेज द इक्विलिब्रियम कंडीशन विल बी अप्लाइड. ठीक है. सो एट इक्विलिब्रियम लीवर का प्रिंसिपल क्या है? यू विल हैव टू अप्लाई प्रिंसिपल ऑफ मोमेंट्स. ठीक है. तो यहाँ पे एट इक्विलिब्रियम क्या आएगा देखो. How to calculate mechanical advantage of a lever, right? So MA of a lever is calculated as follows. ठीक है. I have written that MA could be greater than 1, less than 1 or equal to 1. How did I get it? Is calculated by applying by principle of moments. ठीक है. MA of a lever is calculated by principle of moment. So this we will treat as a equilibrium condition. So at equilibrium what will happen? Clockwise moment will be equal to anti-clockwise moment. ठीक है. So at equilibrium for lever at equilibrium, क्या होगा? L into AF must be equal to E into FG. ठीक है. क्या होगा? By applying principle of moments to the lever at equilibrium, what can we say? Clockwise moment is equal to anti-clockwise moment. What is load into AF? Which moment is that? Anti-clockwise, right? And effort into BF is clockwise. Okay. So for lever at equilibrium, we got this. That is load into load arm is equal to effort into effort arm. Now the new terminology has been introduced. Load arm and effort arm. So this is not DL. This is not DL. Load arm. It is different. So what would be DL? Let us say if it topples left or right. Okay. Let's say load is going down. Then this would be DL. This movement of point A below, that would be DL. Okay, the vertical distance. And here effort displacement will be vertical distance. But when it is effort multiplied by perpendicular distance, that is effort arm or load arm. Got it? Okay, so this is moment. Now, so what do you have therefore? Therefore, load upon effort divided by load arm. Yes. So for lever, how the mechanical advantage is calculated? It is calculated as effort arm divided by load arm. ठीक है? जैसे velocity ratio क्या था? Displacement of effort by displacement of load. ठीक है? So this is how you calculate the mechanical advantage of lever. So when will you get MA greater than 1? MA will be greater than 1 when the effort arm is greater than load arm. Correct? So for Caesar, is effort arm greater than load arm? No. So what will you get? MA will be less than 1 for Caesar. यही होगा ना? Because Caesar का effort arm तो छोटा होता है. Okay? तो force multiplier का example बताओ इसमें. तो उसने बताया था कौन सा? So example is handle of hand pump. Water hand. क्या बोलते हैं उसको? Water hand pump. What machine is that called? Water hand pump. Handle of water pump. उसको water hand pump लिख लो, ठीक है? You can see the diagram. Open your book. Open your book now. The example for class 1 lever. So the question asked is like this: give the example of class 1 lever with mechanical advantage greater than 1, right? Then example of class 1 lever with MA less than 1 is Caesars. So Caesars, okay? Caesars या Caesar क्या बोलते हैं उसको? Caesars, ठीक है? तो देखो उसका effort arm छोटा है, load arm बड़ा है, ठीक है? तो effort arm divided by load arm. तो जिस और depending upon the fulcrum position, इसको left right करो, exactly middle में रखोगे तो क्या होगा? Effort arm will be equal to load arm. तो उसमें कौन सा मशीन है? Seesaw, ठीक है? Seesaw में क्या है? The fulcrum is exactly in the middle, ठीक है? So you can look for more example and figure out. Okay, so see this examples of class 1 lever of every type: MA greater than 1, MA less than 1, and MA equal to 1. Okay, I am just writing one example. So example of class 1 lever with MA equal to 1. So this is seesaw. Let's seesaw, C or double E. Seesaw. ठीक है? और क्या इसके अंदर? So sometimes they will just give you the name of the device. Spoon used to open the lid. Spoon used to open the lid. What kind of lever it is? Force multiplier or speed multiplier? Force multiplier. क्यों? Force multiplier में हमेशा क्या होगा? Effort arm will be bigger than load arm. ये याद रखो. What about pliers? Plier. देखा है सबने plier? पकड़ बोलते हैं ना? Longer. तो क्या होगा? MA greater than 1. मतलब क्या? Force multiplier. ठीक है? बस तो तुम्हें खाली मैकेनिकल एडवांटेज कैलकुलेट करने आना चाहिए डिपेंडिंग अपॉन पोजीशन ऑफ एफ. ठीक है? अब तीनों का वीआर क्या होगा? वीआर भी सेम होगा. जो एमए है वही वीआर होगा. गॉट इट? इन तीनों का वीआर भी सेम एज एमए. हमेशा एमए और वीआर की सेम ही आएगी बिकॉज वी आर डीलिंग विद आइडियल मशीन्स. ठीक है? तो इसका क्या होगा? Same is true for VR. ठीक है? So everybody identify class 1 lever for different MA and VR. और सबके को सेलिना दिखाई दे रहा है. बाकी दूसरा वाला बुक किधर है? वो ब्रदर्स किधर है? ब्रदर्स. आप ब्रदर्स में देखो कैसे एग्जांपल है. You have to identify different categories of machines. Class 1 है. Yes. ठीक है? Yes, yes, उसमें सब दिया होगा. और तो उसके पहले होगा ना एग्जाम का पहले. Yes, sir. Right to example. Okay, shall we proceed? So what is the what category of machine is crowbar? Everybody familiar with crowbar? Yes, sir. वो कौन से टाइप का मशीन? Yes, online students. What category of machine is crowbar? Obviously, class 1 ही है. Class 1 में कौन सा है? Mechanical advantage, whether it is force multiplier, speed multiplier or direction changer. Force multiplier है ना? Crowbar में भी हम क्या करते हैं? किसी को lift करते हैं ना? Crowbar में effort arm बड़ा रखते हैं. ठीक है? So effort arm is big. So it is also force multiplier. Look here, this is crowbar. This one. Okay, so where is the effort arm for crowbar? From fulcrum to the point of effort. ये ज़्यादा बड़ा है. And load arm is small. ठीक है? Okay. Next is class 2 levers. Class 2 levers. खाली क्लास 1 में तीनों टाइप के मैकेनिकल एडवांटेज और वीआर पॉसिबल. ओनली क्लास 1. ठीक है? बाकी क्लास 2 और क्लास 3 सिंगल टाइप की मशीन करेंगे. लेट अस सी हाउ. So class 2, in this case, load is in the load is between fulcrum and effort. क्लास 2 में क्या है? लोड इज बिटवीन fulcrum and effort. तो देखो ठीक है. तो प्रिंसिपल ऑफ मोमेंट लगाने के लिए, so what is the load arm in this case? What is load arm? Distance of load from pivot. ठीक है, fulcrum से जो load का distance है. So load arm. What is effort arm? This is effort arm. ठीक है, effort arm in case of class 2 lever, effort arm is always greater than load arm. तो उसका मैकेनिकल एडवांटेज क्या होगा? ग्रेटर देन 1 ऑलवेज. ठीक है, क्योंकि लोड कहाँ पे है? बीच में. ठीक है, सो लोड आर्म फॉर क्लास 2 लीवर effort arm is greater than load arm. Always. ठीक है, तो इसमें एक ही टाइप की मशीन बनेगी. Therefore, MA will be greater than 1 always. Or ठीक है. Also, ER is greater than. So hope this is easy to understand. It is obvious that the effort arm will always be greater than load arm. So what are the examples for class 2 levers? Then why you would require a meeting? It's like the sense of using the machine. इसका मशीन का वेट और अलग से उठाएगा. इसका मतलब तो डायरेक्शन चेंज है. मशीन है ना, फुली में डायरेक्शन चेंज पता है. ये तो मल्टीप्लाई है. इसका मतलब इसका फुलक्रम बीच में ये जैसे कनेक्ट करता है क्लास. Where is the fulcrum? Side. वैसे कौन सा है? कौन सा? तो एग्जांपल बताओ क्लास 2 लीवर का. नट क्रैकर, राइट? नट क्रैकर. लेमन क्रैकर. यस. करेक्ट करेक्ट. समझ गए. यस. मैंगो कटर. Examples. ये नट क्रैकर हो गया. ये स्क्वीजर की क्या स्पेलिंग हो रही है?
It is correct? Lemon squeezer. तो ये होगा तुम्हारा class 2 leave. Okay, so whatever is the calculate MA, and here also would be same, because we are discussing ideal machines, right? Because MA is equal to VR for ideal machines. Class 3 lever. तो अभी हमने क्या किया, पहले फलक्रम मिडिल में था, अभी लोड मिडिल में लिया, अब क्या बचा ई. नेक्स्ट क्लास में एफर्ट बिटवीन फलक्रम एंड लोड. F and L. ठीक है, सो फलक्रम एक साइड में कर दो. Why the direction of effort is upward in this case? Because load is always load and effort moment should be opposite. Only then you will have principle of moment applicable. Understood? Equilibrium लगाने के लिए क्या करना पड़ेगा? दोनों का moment अलग अलग होना चाहिए. ठीक है? So this is fulcrum. Now you have effort between. Effort. ठीक है, तो लोड अगर नीचे रख रहे हो तो एफर्ट को ऊपर करना पड़ेगा. ओके, so give me examples. Last बताओ. हो गया क्या आया था? मशीन अपने आप काम कर रही है, नो एफर्ट. वहीं बैठ जाओ. Yes, correct. ये बोल रहा है फिशिंग. Fishing. Correct, sir. Yes. Right.
Put 3
Huh?
Put 3
Yeah.
Put 3
Put freedom. What your dentist super top. जाओ ठीक है. So just look for heating illustration. As long as the function is on one side, this one is chopstick कैसे करेगा? There is when you row a boat, okay? So fishing rod is. So when you do this rowing, तो क्या करते हो? एक हाथ से पकड़ो, एक साइड में, and then the load is movement of water, right? And then you are pulling your hand in the middle.
Morad is also an example.
हाँ,
Morad is also an example.
Correct. So we'll come to levers inside human later on. First, let us complete all the machines. Okay. So what was it? What is it called? Oar. Huh? What is it called? Oar बोलते हैं ना उसको. To row the boat, what do we use? Oar. Okay, so just look for diagram in your book. Short handle oar, this way. The oar is actually held by one hand. One end of the oar is held, the other end is in the water, and you apply the effort in the middle to row the boat. Okay, so sports racing, I mean, it is used when you have so many boat rowers are sitting on a single boat. So that oar is right now acting as class 3 lever. But there are certain oars which are fixed on the boat. Then that becomes class 1. So oar has two examples. If the oar is fixed on the boat, okay, then you are rowing it like this. Okay, then it becomes class 1 lever example. So sometimes the questions are asked. The same machine, okay, has a different functionality depending upon where it is fixed. So be careful. And then also you have examples of each class of levers found in human body. Okay, so what is the first class 1 lever in human body? What is class 1 lever in human body? So nodding of the head. Okay, nodding of the head. So where is it hung? In between, right? Fulcrum in the middle. So that is, so nodding action of head is example of class 1 lever. So your head is divided into two parts, right? The back part is, if this is effort, then this becomes load. Now this is effort, this is load. That way. So load and effort is switching. Okay? You see the diagram in your book. So nodding action of head is example of class 1 lever. What is that? In human body. Nodding off. So this is the fulcrum. This side is this side is. Okay. So nodding action of head. Then what is class 2? So how to remember class 2? Class 2 में क्या होता है? What is in between? Last two? Load. Okay. So load कैसे आएगा? Fulcrum from the edge. So when you're lifting your body up the toes is fulcrum, and load is body weight. How are you lifting the body? By stretching your calf muscle. Where is effort? Calf muscle, right? That's how it is. Effort is on one side. There is body weight, center of gravity, right? So it will fall between toe and calf muscles. Got it? That's how it is. So lifting the body on toe. So how do you lift it? Okay, by stretching. Okay. So this is how it will be. Okay. Then the third lever example is raising a load by a forearm. This is all. Forearm. क्या हुआ? प्रेशर बहुत ज्यादा है.
होटल में मेरा ये